All right, so this is going to be section 2.8 in your notes, and the topic is function composition. Okay, so last time you guys learned about the 4 basic operations of functions where we can add, subtract, multiply, or divide different functions, but we can also combine them through an operation called composition. Okay, basically the composition of 2 functions is found by plugging in one function into the other. Okay, and this is notated as f of g of x is how we would read that. Okay, so we just kind of read it in order. So f of g of x. Okay, the result of the composition of 2 functions is also a function. Okay, so let's just look at these 2 that were given. I'm going to go ahead and color code these. So I've got f of x is equal to x squared minus 1. And g of x is equal to x minus 3. So let's start by finding f of 4. Okay, so f of 4 is asking me, since it's an f, I'm going to be looking at the pink function. And basically what this is saying is everywhere in our f function that you see an x, I need you to replace it with a 4. Okay, so we're going to go through and I've got x squared, so I'm going to plug in 4 squared. Okay, so I've got 4 squared and then minus 1. All right, and then I just have to go ahead and simplify it. All right, so f of 4 would be equal to 4 squared is 16, and then 16 minus 1 is 15. Okay, so we've been plugging in different values like that using function notation for a while. Now we're going to see what that looks like if I'm given f of g of x. Okay, so just like before, I'm going to write it down first, f of g of x. And just like f of 4 said, everywhere you see an x in that f function, you're going to plug in a 4. Now everywhere I see an x, I need to plug in this whole function, g of x. Okay, so I'm going to go ahead and write f of g of x is equal to, and start going. Okay, so in this function, I see an x right there. It's x squared minus 1. So instead of 4 squared minus 1, I need to replace that x with the whole g of x function. Okay, so I'm going to have x minus 3 squared minus 1. Okay, so hopefully what you're noticing is it's the same process as plugging in just one number. It's just that you are going to replace the whole function. Okay, and now we can simplify this as far as we need to. Okay, x minus 3 squared is x minus 3 times x minus 3. Okay, and then we'll keep that minus 1 on the outside there. Okay, and then if we distribute this through, we'll end up with x squared minus 3x minus 3x, and then plus 9. And then we still have our minus 1 on the outside. Okay, so if I combine these like terms together, I can write a final answer of f of g of x is equal to x squared, and then negative 3x minus 3x is negative 6x, and a 9 minus 1 is 8. Okay, and so that would be the simplified standard form of f of g of x. Okay, so let's look at another example here and see if we can now use it to do something. Okay, so the first thing says find f of g of x. We're given 2 new functions here. We've got f of x and g of x. And then we're going to use that result to find f of g of negative 1. Okay, so I'm going to start by writing down what I'm looking for, f of g of x. So what that tells me is I'm going to go to my f function, so the one I've got underlined in pink here, and everywhere that I see an x in that function, I need to plug in this whole function g of x. Okay, so f of x is 3x squared, so 3 times x squared. So I'm going to have 3 times the whole g of x function, okay, 2x to the 3rd power, is what gets plugged in for this x value here. So I've got 3, and then all of my g of x squared. Okay, and just like before, let's go ahead and simplify this. Okay, so 3 times 2x cubed squared. So I'm going to go ahead and write 2x cubed twice. Okay, that's what it means to square something. All right, and you can multiply these in any order, but I'm going to go ahead and multiply these 2 together first. Okay, so we'll leave the 3 where it's at. So I've got 2 times 2 is 4, and then x cubed times x cubed, so this is x times x times x times x times x times x, we're going to have x to the 6th power. All right, and lastly, I'll multiply these two together. All right, so f of g of x, all simplified, is going to equal 12x to the 6th. Okay, 4 times 3. 12x to the 6th. So that's our first step there. It said find f of g of x. And now we're going to actually use this result to find f of g of -1. Okay, since I've already done all of the hard work of finding f of g of x, now all that's left to do to find f of g of -1 is that everywhere in this function that I see an x, I now just need to plug in a -1. Okay, so I'm going to have 12 times x to the 6th power, but everywhere I see that x, I am inputting a -1. All right, so let's go ahead and use our order of operations. We're going to start with -1 to the 6th power. That's -1 times -1 times -1, right, 6 times. Okay, so all those times, like that, since it's an even number, right, it's going to turn back into a positive. So negative times negative is positive, another negative times negative is positive. So this is just going to end up giving me a +1. All right, and lastly, 12 times 1 is just 12. Okay, so we can say f of g of -1 is just equal to 12. Okay, now you could have also started with this guy and plugged in -1 into the function g, and then plugged that result into the function f. But since we did all of the hard work of composing those functions at the beginning, then there was only one thing we had to plug it into there at the end. Okay, so let's look at one more example here before we look at a word problem. All right, so this one has a function composition and then a little bit of review from the last section of multiplying two functions together. Okay, so we've got our two different functions. Here's f of x, here's g of x, and we're going to write a new function, k of x. Okay, and k of x is going to consist of g of f of x. Okay, so basically we're going to do the same thing we were doing before, we're just naming it k of x. Okay, so let's go ahead and write it down. I've got g of f of x. Okay, so what this is telling me is I'm going to be looking at my g function, right? So the one in green, and everywhere that I see an x in that function, I'm going to need to plug in all of my f of x function. All right, so let's see, I've got x squared, so I'm going to put a parentheses, x squared, and then plus another x. Okay, so those two little pieces in green here, I just have in parentheses right now. All right, so everywhere I see an x, I need to plug this whole function in. So I'm going to have 4x cubed squared, that first x value gets plugged in there, and then plus another 4x cubed. Okay, so now that I've got it plugged in, we just need to simplify, and then we're going to, again, name this k of x. So let's simplify. 4x cubed squared. I'm going to go ahead and write it down twice. Okay, here's what it means to square that. And then I've got plus this 4x cubed. All right, so multiplying these two things together, 4 times 4 is 16. And then x cubed times x cubed is x to the 6th power. Okay, and then I've got a plus 4x cubed over here. These two things are not like terms. We cannot combine them together. So this is as simplified as it can get. And normally I would write g of f of x equals all this stuff, but we just decided to rename it k of x. And so if I just use that new label there, we are all set for that first part. Okay, and k of x would equal all that stuff, 16x to the 6th plus 4x cubed. All right, let's do this last little problem over here. It's asking us to name another new function, h of x, and we're going to name that function by doing f of x times g of x. Okay, so let's go ahead. Yeah, I'll just go with pink. Okay, so f of x is my pink function here. Okay, so I've got 4x to the 3rd power, and I'm going to be multiplying that times g of x, okay, which is equal to x squared plus x. Okay, and I'm going to be naming that new function h of x. Okay, so let's go ahead and simplify. This time I've got a monomial times a binomial, so I am going to need to distribute this into both terms. Okay, so I've got h of x is equal to, we've got a 4 times 1 here, so 4 times 1 is 4, and then x cubed times x squared, so x times x times x times x times x is x to the 5th. Okay, your kind of shortcut for exponent rules is to add your exponents when you're multiplying. Okay, so we've done our first term, 4x cubed times 1x squared is 4x to the 5th, and now this 4x cubed needs to multiply this x. So it'll give me 4x to the 4th power, okay? X times x times x times 1 more x. And again, these are not like terms. This is as far as we can go. So this would be my function h of x is equal to 4x to the 5th plus 4x to the 4th. Okay, so in the next video, we're going to look at a few like word problems or how we can deal with this idea of function composition from graphs, and then that'll be about it.